Hey there, party people. So let's talk about cluster 10 of your textbook and cool stuff that's going on there. So we're going to talk a little bit about the learning sciences, certainly a great deal about cognitive and social constructivism and applying constructivism. I'm going to skip out of service learning and learning in the digital world because learning in the digital world really happens in another course already, so I'm not going to worry about that. Besides, I teach that other course. All right, basic assumptions of the learning sciences. So the idea here is we have experts that have this deep conceptual knowledge. So it's a deep understanding beyond the facts and procedures. Learning outcomes from learners. Schools must create effective learning environments, and we're going to talk a little bit about the historical aspect of that. Which has implications on in the classroom and curriculum and assessment in terms of real-world problems, transfer school learning. You're going to love my example to life, and prior knowledge and beliefs are key. Teachers need to begin with what students know and then build on top of that. So that brings in that whole aspect of scaffolding that's talked about in the textbook. Reflection necessary to help deep conceptual. Well, we already saw that in metacognition, right? So the idea is to reflect on what we know or what we've learned is an important aspect to kind of put a pin in it to make sure that it's concrete. Okay, so they go over this idea of embodied cognition. So theory that cognitive processes develop from real-time, goal-directed interactions between humans and environments. So that's cause and effect, right? So you do something, something happens. You witness it, and then you change in line or you change after the fact. So we interact through our senses and bodies. I put my hand into a flame, it feels hot, I take it away, right? I learned that that flame's hot, and then I start to build knowledge on top of that. What can it be used for? What application does this have? Keeping me warm in the winter, etc. Cognitive development related to sensory motor engagement in the world. Again, so it's about interaction with the world. They give the example of observational learning. So activity in parts of the observer's brain matches that of the person involved. So if I'm observing somebody do an action, it actually activates the same portions of my brain and causes brain activity, even though I'm not really performing that task. I'm being empathic. I'm actually watching the other individual perform that task, but it's still activating the same parts. Cognitive and social constructivism. So the whole idea is we want students to construct meaning for themselves, right? So we build up or we walk up the stairs of knowledge, basically, right? One level builds on another level, builds on another level. So they give the example of the textbook of the nurse's station calls down to calls down to a child that's in a room in a hospital. And the nurse says, are you okay? Is everything all right? Do you need anything? The child is like, okay, I've never heard an intercom system before, so that's not within my scope of reality. I don't know, I can't make sense of what's happening. So the child thinks it's the wall that's actually talking, and to make sense of her world at that particular point, and says, I'm fine, wall, how are you? So again, we're placing a context to what we can make sense of our reality. That's the idea of constructing knowledge. So how do we fit those bits and pieces in to a cognitive schema, right, that makes sense for us at that particular point in time in development in that particular situation. The example of co-constructing knowledge, and this is really actually a mother taking a really good advantage of so many teachable moments and having the energy to do so with her child in the grocery store, which is great. So the child's shopping with the mother, the interaction, she says, the kid says, oh, let's go get the ice cream first, and then we have a mechanism of recall. Do you remember what happened when you left the ice cream out on the counter? Oh, it melted, right? So there's our science curriculum coming in. So how we go from solids to liquids. And then the mother says, well, I probably want to get the other stuff first and get the ice cream last because remember, it wasn't out in a long amount of time before it melted. So we go through this this logic system of, again, interacting with the environment, right? I left the thing out on the counter. It was hot. It melted. I don't get to eat ice cream. So it's an interaction with the environment, and then I learn from that interaction, and it helps me construct my knowledge from reality and situations that occur. So constructivist views of learning. So in constructivism, the view emphasizes the active role of the learner in building understanding, kind of what I just discussed. Making sense of information and kind of putting it in line, right? Putting it into basically a cognitive schema of how things work, because that's really what the mechanism is. There's no one constructivist theory of learning. There's two central ideas, though, that kind of exist out there that they agree on. Central idea one is learners are active in constructing their own knowledge, just like we had with the ice cream example. He learns from that interaction with the environment to get the knowledge, right, to construct the knowledge. And then there's the second piece, which is social interactions are important in knowledge and the constructive construction process. So I can learn from others within the environment as well, and they can fill in gaps for me in knowledge or help me create more of a linear understanding of my own knowledge. So there's two forms of constructivism. The first one's kind of the psychological, and that's like stage one. That one has to do more with like how we came up with ideas and then implemented them. So how reality focuses our knowledge, and then we use that knowledge and apply it to change our reality. Okay? I'll kind of show you what I mean in a minute, though, through a physical example. And then there's the social focus. So the idea is that we can increase abilities to participate with others in activities that are meaningful in the culture. So all learning doesn't need to be formal, right? It can be informal learning, and I can learn from that experience, and that also has application. Okay, so what this structure is called is a panopticon. So it's a guard tower. And the idea of this was kind of, in education, was brought forth by Foucault. So the idea is you're controlling a large population of people. So the idea comes to our head, right? Foucault, in his and it wasn't he who created the actual model, but he applied it to institutionalization. So, in our head we think to ourselves, how can I control a large population of people that are deviant? In this case, it's prisoners that are deviant, and they need a high mechanism for controlling their behavior. So they all need to be watched at the same time, but imagine the number of people it's going to take me in this particular cell block of, say, 300 people. So what do? We put a central tower in the middle that can see into all of their cells at the same time, so there's no blind spot, with adequate lighting. And then we only need really one guard in the tower to observe. If you mirrored those windows, so that you don't know where the actual guard is looking at any particular time, you have to make the assumption you're being watched all the time as a prisoner. Okay, so how does this have an implication? So the implication is, number one, we dream up in our heads, in our heads we create something like the reality is we have a whole bunch of people that we need to control. So how do we control that? So let's dream something up. This isn't a natural occurrence, right, of something that naturally occurs in nature. So what happens? We design something, again, using the parameters of what we need to do, and then we implement it. And that then affects our reality. So then we have a new structure that we've built that changes our reality, right, of how we can make people conform to a norm. And that's really what that psychological first phase is. It's about trying to normalize behavior and make people fit into that normalized behavior pattern. How does that imply on schools? Here's me at the Anderson Schoolhouse, and what I'm standing on is a stage at the front of the room, And this was common practice to have a stage in the room from at least the 1880s, I can tell you, through the 1940s, late 30s, 40s, locally anyway. So to have a stage in the front of the room so the teacher can see all of the students in the class at the same time, right? And the message is authority, but the message is you're being watched, just like the panopticon, right? So again, we're talking about normalizing behavior, fitting into normalized pattern, and imposing structures. So somebody invented that reality in their own heads, and then that became reality. And then that forms what happens next in terms of behavior in the room. Okay, that one's a little more complex than Vygotsky's idea of social control, which I'm a big fan of, or social constructivism. So the idea is that social interaction, cultural tools, and activities shape individuals' development and learning. Like I said before, learning is not just a formal endeavor. We learn from our parents, we learn from our siblings, we learn from friends. So it's the second wave of constructivism in which we're putting learning in social and cultural contexts. That kind of also implies that we try to align things to the real world. It bridges both the social and psychological views of constructivism. Why? Because the social part of the group will actually control the group to form a normalized pattern of cognition and behavior, right? So what's the norm in terms of thought, and what's the norm in terms of behavior? Appropriating the outcomes of working with others. So appropriating in this case is the learner internalizes knowledge and skills developed, interactions with other persons, or with cultural tools. So constructivism, if we put a generalization on it, so we create a general definition of it, concerned with how public knowledge in disciplines such as science, math, history, economics is constructed. So how does it get constructed over time? Not a focus on individual learning itself, but how we actually form ideas and concepts. Interested in how common sense, everyday beliefs are communicated among group members. So how do we normalize ideas within a society that this aspect is okay and other aspects are not okay, right? So the key question on learning from this is, so you have proponents of different perspectives on constructivism, and they disagree about answering key questions about learning. So how is knowledge constructed, right? So we can go through several different dichotomies of how they think knowledge is constructed. Is knowledge situated or general? So do I learn it in one particular stance? Is in schools, is it situated there and only applied in schools, or can it be transferred out? Now, I would suggest that it can be transferred out, and it's an equation of motivation and necessity. For instance, let's say you have a margarita, and you need to extrapolate the knowledge of the margarita, which is the recipe basically, the knowledge of making the margarita, to a larger quantity. So let's say I need to make a pitcher of margaritas. It becomes a necessity for me to be able to do some math. So if I know from the recipe that 2 parts is tequila and 1 part is freshly squeezed lime juice and 1 part is triple sec, right? And I know that my pitcher contains 72.7 ounces, or will contain 72.7 ounces. Then I need to know that I divide the 72.7 by 4 to give me 4 equal parts. And then I multiply the 18.1 ounces times 2 to give me the amount of tequila that I need, right? And then I have the other for the lime juice and the other for the triple sec. If I wanted to create this a further problem, right, I would have to figure out, because it's freshly squeezed lime juice, how much lime I get in fluid ounces, lime juice I get from each lime, to know how many limes I need. So again, it's an issue of division and multiplication in this part, and applying those in an otherwise static learning process. So when I'm learning ratios in school, I might not have an application for those ratios until I find a real world application of those ratios in which I need to do something. The same thing can be with, say, if we wanted to use a more school friendly example. I know you're all in more or less above 21 years of age. So I use this example, again, as a real-world example for actually applying something to a recipe, right, and multiplying it out. But we could use the same thing if we're talking about ratios and baking bread or making pizza or any other thing that actually contains a ratio and a function for some multiplication and division. We can also apply it to, say, we give the students, again, problem-based learning, which is yet to come within this particular cluster. Problem-based learning, if we give the child the dimensions of a bedroom and say you need to, or each wall in a bedroom, you need to paint all 4 of these walls the same color, how much paint do you need in fluid ounces, given the how many square feet is covered by how many ounces of paint from the can or gallons of paint from the can, and then we actually break it down so they can solve that problem. So there's 3 explanations on how knowledge is constructed. Directed by realities, truths of the external world, so information processing. So individual reconstructs reality, builds accurate mental representations. So again, if we go with our panopticon example, right, we're kind of reconstructing reality, and we're building a mental representation before we build the actual representation of what that building would look like to have a purpose, to have control as the purpose. Directed by internal processes, so the idea Piaget of organization, assimilation, and accommodation. So we build on knowledge, so we get new knowledge abstracted from old, right? So, a lot of lesson plans in the past have basically said, hey, what did you learn that's new from this, or what was the precursor step before this, the pre-existing knowledge that needs to be there before we build on that knowledge to get here. So it kind of gives us a scope and sequence of curriculum, which is important. Directed by both external and internal factors, so knowledge grows through interactions of cognitive and environmental social factors. So when I gave you the candle example in the flame, so I put my hand over the flame, that also doesn't stop a mother from saying to the child, oh, don't put your hand in the flame, it's going to burn, right? Even though I might not understand what the sensation of burning is. But I do, because she's going to extrapolate and tell me that it's going to hurt. It's going to make me cry, right? So by creating that social learning that's built in there, that can replace the actual sensation of understanding what the fire is going to do to my hand and burning, because there's been an analogy built for me of what it's going to feel like. So then the book asks the question, is knowledge situated or is it general? So is knowledge general, internal, and transferable, or bound to time and place in which it is constructed? Well, if that was the case, then everything I learned in school must stay in school, which would be a huge issue in transfer, which it kind of is, but not everything. If it's situated, the skills, knowledge tied to the situation in which they were learned, difficult to apply to new settings. So not like learning in school, more like apprenticeship. So we learn on the job and we can then extrapolate out. Explain learning in factories, street gangs. Again, it says basically we can learn in different places. So the other complexity is that a truth in one time and place can become false in another. So I can't obviously transfer all knowledge into every situation. All right, just because it exists in one situation doesn't mean I can generalize in another. The clearest example I can think of is, if you flush a toilet in the northern hemisphere, the swirl goes in one direction. If you flush it in the southern hemisphere, it actually goes in the other direction. So if I was born to the northern hemisphere and flushed toilets only in the northern hemisphere, I would have a false sense of that particular reality given that particular place. Community of practice, so social situations, context in which ideas are judged, useful, true or not, that can change by social situation. Table mannerisms in one place might be different than, say, in another place. So my learning that went into and practice that went into eating in one country might not be transferable to another country. And also there's a lineage there, so ideas might be rejected over time because there's a new accepted reality over time. I'll give you another example. Current legislation in my home province of Ontario now says that marijuana is going to be legalized. So when we have the catchphrase back in the 1980s of just say no to drugs, we use a logic pattern, marijuana is a drug, then hence for Nancy Reagan I must say no to marijuana, but now the legislature says it's okay. So under a legal definition for dispensing uses, whatever the parameters are of the law, it's okay. So that's a reality, that's knowledge that's changed, a concept that's changed over time. Another key question, can knowledge from one situation transfer to another? Well, that's kind of what we just summed up. Common elements of constructivism in student-centered teaching. So again, this is kind of putting the student at the center. So no more you at the front of the classroom preaching for direct instruction, but rather you kind of create a problem and the children focus on the problem and their methods for solving the problem. So there's 5 conditions recommended that by many constructivists approach. Embed learning in complex, realistic, relevant environments. That means problems, basically, that are real-world based. Provide for social negotiation, shared responsibility as part of learning. So what's the child's responsibility? What do they have to produce as a product at the end of the process? Support multiple perspectives, use multiple representations of content. So, doesn't need to be pencil and paper, can be multimedia, can be a diorama, can be a drawing. We're talking here about differentiating assessment. So assessment can be different to best represent that particular concept. Like we've been doing in science with atoms for many years, because you can't see them unless you blow them up into a macro scale, and then you're attaching little circular things together with rods. Nurture self-awareness and an understanding that knowledge is constructed. So the idea is that there's going to be steps along the way. It's not going to be a sudden osmosis of knowledge that's suddenly assimilated by the child. And encourage ownership of learning. Well, again, if it's product-based or project-based or problem-based with a physical outcome, usually ownership comes hand in hand with that. Complex learning environments and authentic tasks. So what I just said about real-world learning, the idea is we want to incorporate that into the classroom. So students should encounter complex learning environments, so problems in learning situations that mimic ill-structured nature of real life, because real life stuff happens, things break, you need to fix them, you don't know what's wrong with them before you fix them, so you need to diagnose and then troubleshoot, right? So that's kind of the process we're talking about, to use kind of a mechanical engineering perspective of it. Embedded in authentic tasks and activities. So again, we try to give real world tasks so they can apply them out and the transfer is a little bit easier. Scaffolding, so we have support for students provided by teachers, helping them find resources, keeping track of progress, breaking larger problems down to smaller ones. There's a whole bunch of realities to scaffolding. I'll throw an article up online as supplemental reading, one of my articles that I've written on scaffolding, just so you get an idea of what the scope can look like for scaffolding students towards success. That happens to be college, but it is also applicable in K-12 as well. Consistent with situated learning perspectives. So social negotiation kind of revolves us back to Vygotsky again, right? So the idea is that if we're learning and collaborating with others, we respect different perspectives. So that allows us a degree of integration. If there's a difference within the classroom, and there will be a difference within the classroom in most classrooms, on socioeconomic status, race, religion, etc., because then we're creating a normed reality for the generation of knowledge, right? We're all agreeing on what's the reality of knowledge for that particular concept by working together. So we establish, defend, own positions, respect positions of others. So that gives us tolerance for difference. Tolerance in this case is a proper word because we have differing opinions. Tolerance when applied to race or religion or other differences, I have a great distaste for the word because it should be understanding, cultural understanding, religious understanding of other peoples and other beliefs, rather than tolerance, because that means that I'm firm in my own perspective and I'm not really going to respect theirs. I have to respect the positions of others, though when we talk about argumentation. So if somebody's defending a position in terms of logic and arguing with me based on point counterpoints, then that's reality, and we negotiate our reality and renegotiate our reality through that process of conflicting logic between people and trying to understand their perspective. They're having empathy with their perspective, understanding their histories, understanding their argument for why that is reality for that particular piece of knowledge. It involves taking and listening to one another. So you actually have to listen and talk. Again, perhaps by putting emotion apart, but to try to understand and listen. Intersubjective attitude, so we're building shared meaning of finding common ground, exchanging interpretation. So you have to walk in with the openness of the motivation, which most K-12 students are, with the motivation that I'm open to changing my ideas. It's more challenging in an individualistic, competitive structure, structures or cultures like the U.S. Not just there, but if you have large differences in socioeconomic status, like for instance in Brazil you have a very poor lower class, you have a very rich upper class. It's hard to get both perspectives in the same room and find common ground. Understanding the knowledge construction process. So we make students aware of their own roles in constructing knowledge. This again reflects on metacognition, right? Our assumption, beliefs, experiences shape what we know about the world. Different assumptions and experiences lead to different knowledge. So if I have a student that lived in a different country, their reality and their assumptions might be different. That doesn't mean they're worse or better. It just means they're different in that knowledge. So for instance, I'm going to give you a Brazilian example once again. So here in the United States, the fathers of aviation were the Wright brothers. In France and Brazil, the father of aviation is a man by the name of Santos Dumont. And the first flight took more or less at exactly the same time periods, okay, the same ranges of times. And since it wasn't very well documented by media, we don't know who really was first. So just because the assumption's there doesn't mean that it's wrong, having come from France or Brazil. It means that it's a different perspective. Now, I wouldn't go as far to say it's an alternative fact, but it's a different perspective on validated knowledge. Awareness helps us choose, develop, defend positions in self-critical ways while respecting positions of others. So I need to respect the Brazilians in the fact that they believe that, because I can't disprove otherwise, and they can't disprove otherwise that it was the Wright brothers. So it coexists as knowledge. Student ownership of learning. So constructivist theory changes the focus of teaching, puts, again, its emphasis on both the problem, product, process, and the student's development as part of that. Puts the student's own efforts to understand at the center. That's what I just said. And teachers design student-centered instruction. Classroom applications encourage meaningful learning, so we want complex, meaningful, problem-based activities, collaborative work, support for task-oriented dialogue, etc. That's kind of what we just discussed too, in terms of argumentation. Constructivist approach supports students with scaffolding. We talked about scaffolding. Characteristics of scaffolding, we're talking about adjusting, differentiating, both assessment and instruction. So instruction is going in different sensory means, different learning styles, different ways of getting the knowledge to the students, and tailoring responses to students. So how we actually adapt our response to our individual students given individual development. Fading, so we move away. Our supports as the student understands more, so that you don't need to be smothering. You can fade away in terms of how much support needs to be there as they take on the task themselves, and eventually transferring responsibility entirely to the student on their own. Inquiry and problem-based learning, I've already kind of hit on this a lot because I'm a big proponent of this for the last 20 years. So, you know, it doesn't matter where it came from, but basically you're posing a problem, and then the students gather data and they test their conclusion to solve the problem. That's the idea here. So again, inquiry process, teacher poses a problem, students do the following. So they formulate a hypothesis, they collect data to test the hypothesis, draw the conclusions, reflect on the original problem and thinking process. There's your metacognition needed to solve it. So how did I solve this? Would this be applicable in a different situation, etc.? So again, we create those linkages between how we do things. Problem-based learning, they say, grew out of the medical field. Develop useful, flexible knowledge, not inert, so we can apply one situation to another. Again, we're talking about transfer. Problem-based learning provides students with realistic problems that might not have a right answer. So students confront a problem, the problem launches inquiry, and the students elaborate to solve the problem. True problem-based learning involves real problems. Students' actions matter. Some problems are engaging, but not authentic. Okay, so I'm going to end here, because what I'm actually going to do is, in the assignment, I'm going to have you identify all the aspects of constructivism and this chapter within the particular school assignment that was given to these particular students.